Thanks, everyone. We'll start the next session today. Our first speaker is Jacquie Tran. She's working for High Performance Sports New Zealand and is going to talk about data practices and problems in performance sport.
Thanks, Simon. Kia ora, ngā mihi kia koutou. Thank you so much for having me. I want to say firstly thank you to the organising team because I know events like this don't come together without considerable effort, and thanks to the volunteers. So please say a warm thank you and a hug or a pat on the back for the blue shirts when you see them. Thank you also to the sponsors because this stuff doesn't happen for free either. Someone shells out generally, so thanks for making it happen. This is probably a grander title than what I'm actually presenting. I've been fortunate through a few people that I know here, Kim and Anna, to have presented to a bunch of different groups who are not necessarily sport people or sport scientists. And something I've learned is that, or perhaps had reinforced, is that the work that we do in elite sport is super niche. So what I thought I'd do today is more of a selection of cool things that people are doing with data in sport using R. That's broadly the summary of what I'll discuss today. If you want to take photos for free, the slides are online, and I think I've tweeted out the link just now, but I'm sure that'll be shared as well through the usual channels. So you can take photos if you like. There's nothing particularly confidential or anything in here. As Simon mentioned, I work at High Performance Sport New Zealand. I moved over here a couple of years ago to take up a job as a researcher in the Knowledge Edge for Tokyo team, and I'm based up at the AUT Millennium facility on the North Shore. I've been working towards, in some form, studying or working in sport for a long time, since I was 15, and that makes me pretty narrow-minded sometimes about sport. And so what I would like you guys to do is to take a moment to reflect, and I'd like you to think about what it is that you think about when you think about sport. So given the crowd, some of you might be thinking, ew, sport, no. Which is fine, that's cool, it's not for everyone. Some of you might love sport. Many of you are Kiwis, either by birth or in spirit and by choice. You might be thinking about teamwork and what happens when athletes come together and work together to achieve an outcome. You might think about the thrill of a race. Might actually use the clicker, thanks, Hero. You might think about the bang and crash of collision sports. You might think about sitting in a stadium filled with fans and the roar of the crowd when their team kicks a goal. So those are some of the messages and some of the experiences and emotions that people think of when they think about sport. And that's great. It's a lot of what brings people into sport and keeps them interested and engaged and contributing. For those of us who work behind the scenes, it's usually a lot less glamorous than that. My background is as a sports scientist, so our interests are in using scientific methods and knowledge to enhance the way that athletes and teams prepare in order to create exceptional performances and then sustain those performances over time. And one thing I was going to mention right at the top is it's pretty cool when you can have JJ Allaire kind of foreground your speech for you, so that's cool. So thanks. We didn't even coordinate that beforehand, so that's sweet. So behind the scenes, it's not that glamorous sometimes. It's not the lights, it's not the colour, it's not the fun and the excitement of the pinnacle event or the competitive event. And especially as a researcher or as a data person, it looks like this most of the time. Maybe not even quite this glamorous and posed. Every time I look at this photo, I pick out something different, and I really like the bowl of pistachio shells, which is that's pretty common in our team. We have a hacky hour that we run semi-frequently, and snacks are very important as part of that hacky hour. But we spend a lot of time working with information of all sorts. As a sports scientist, you might be a physiologist, so you're interested in the ways that the body responds to and meets the demands, the energy demands of training and competing. And so the kinds of data you might work with include heart rate data, or sweat rate, or breathing rate, or expired gas analysis, or carbon dioxide, expired and oxygen consumption. And so there's data everywhere. You might be a biomechanist and you're interested in measuring joint angles and forces. You're interested in tracking people in a 3D space. You might be a psychologist and you're regularly administering psychometric scales and tracking people over time and seeing how they do or don't shift on those scales. and making judgments about your interventions, your psychological interventions to best support them. So data is everywhere in sport today. It wasn't always like this. So sports science as a field is fairly new. It's, depending on when you think it started, it's probably about 100 years old, give or take a few decades. And it used to be very, very difficult, not in the very distant past, to gather comprehensive, rich, high-resolution information. So I want you to have a think about this. Imagine that you want to measure how fast an athlete sprints over a short distance. Have a think about how you would do this. Any suggestions? Stopwatch, manual stopwatch, great, yep. High-speed camera. I love the suggestions that come from a tech group, data and tech group. Yep, high-speed camera for sure. You calibrate the camera and know the distance someone's covered and measure it that way based on frame rate and timestamps. Yep. Wearables, did someone say? Yep, wearables, so say a GPS device could be used to track how fast someone runs over a certain distance. So there are a bunch of ways to do this, and people are more and more comfortable with this because these technologies are accessible to us through our smartphones and our personal devices more and more. If we were in 1927, this was the high-tech way to do it. So the very well-dressed gentleman there in the tie and the shorts is A.V. Hill. He won a Nobel Prize for his contributions in physiology, and he's one of the pioneers of sports science, really. This idea that it was worth understanding how the body responds to and adapts to exercise and sports training and performance. So what's happening here is that we have a speed gate set up. We have a sprinter who is wearing a belt. It's very hard to see in this, but if you have a closer view of this image, you can see there's a small black belt that he's wearing with a magnet attached to it. And the wires are effectively magnetometers. They're picking up changes in the magnet passing past that gate. And then we can log the time that the magnet passed each gate. We know the distance between the gates, and so we can then calculate velocity and acceleration between the gates. So that's pretty cool in 1927. Today it looks like this. Today, if we're in a lab setting, it would look like this, where we set up gates. We have infrared beams from the back gates, the ones shining the green light. They project an infrared beam to the reflectors, which are the gates that are closer to us as the viewer. And those reflectors send the infrared beam back to the original gate, which has a receiver. When the athlete runs past the beam and breaks it, then we log the time, and then we know the distance between the gates when we calibrate our setup, and then we can do exactly what A.V. Hill did, which is measure the velocity and the acceleration between those gates. So with advances in technology, we have been able to rapidly increase the kinds of data that we can collect, the quality of that data, the resolution of it, and we can do it digitally, which is awesome. But the problem is this. We have more data than we know what to do with in sport, and it has come very quickly for our industry. I've been working in sport for now 17 years, so if you can do some quick mental math, you know how old I am. And in that 17-year span alone, we've gone from, in my first year, sitting in a lab doing hand-timed sprints, to then the cool thing at the time was that we had a light gate set up, but it was all wired. So we had to make sure the wires weren't a trip hazard for our athletes, to now this setup, which is completely wireless. And so that's, in one example, how quickly we've come in a 17-year span. So we don't necessarily have a lot of great skills in sports science in terms of working with data that's high resolution, high volume, that is in different formats as well. So we work with, some of it is tabular, some of it is streaming data, some of it is video, some of it is from multiple sensors integrated to track a particular event, like Hawkeye in tennis, which is a 10-camera, high-resolution, high-speed camera setup and produces 3D reconstructions of tennis matches. So that's a kind of data that sports scientists, by and large, will not have been exposed to in their training. But the cool thing, and being our people here, is that there's heaps of great tools being created all the time. I'm really highlighting a small selection of things that are being done in this space. It's grown rapidly in the last few years alone. When I started using R in 2013, there wasn't much in terms of data tools specifically for people in sports analytics, and now I actually had to just exclude a bunch of things from this talk because there wasn't enough time to cover it all. So I thought in terms of data problems, I thought I'd just couch it in the general data process that would be familiar to all of us. So gathering data, there's some tools that have made this really useful. Before I moved over to New Zealand, I worked in Australian football, and boo, everyone, like no one ever has any kind of reaction to it in New Zealand, which is always funny to me. I say it in Australian, people are like, wow, you worked in Australian football, and people here don't care at all. It's great, it's great, it's great for the ego. So we, we're interested in gathering information about how our teams performed and how our opponents have performed and how that tracks over time so that we can try to find an edge. One of the difficult things is that there's 18 teams. There's 22 players on the field for each team, for every game. So there's a lot of games, there's a lot of data, purely even in the count statistics. So counting kicks, counting marks, counting handballs, counting substitutions. If you only look at the count data, you still get a huge number of data points from a single match. So to then try to gather that for a whole season, do that accurately, is a total pain unless you have a package like Fitzroy to do that. So with a fairly simple bit of code, we can load the library and then pull in statistics for, in this case, I've pulled in statistics for any match played in 2019. And that takes a couple of minutes on my computer to run. And then we get a nice, tidy data set, which, as you can see, has an awful lot of information. We can see that it's got one row per player per game for that season. And for a sports data geek, the mind kind of boggles about what you could do with this information. A similar kind of approach is NCAA Hooper, which is a package that retrieves basketball data from US men's college basketball. And you can get play-by-play data thanks to ESPN and their API. So single line of code, you point to a game ID based on what the URL is, and you can see I've provided it there. And you get play-by-play data. So this is even cooler to me because the resolution is higher. Play starts. North Carolina win the jump ball. A person makes a jump shot, which is assisted by another person, and so on. Oops, I just skipped ahead there. So we can then start to not just look at summaries of games. So X player kicked 30 kicks. We can actually look at the dynamics of the game. So who did what and when, and who interacted with who. And that gives us more useful information when it comes to tactics and trying to identify patterns in play and trying to either disrupt another team's tactics or identify patterns in our own play and assess whether they match the strategies that we're trying to implement. A lot of the work that's being done, a lot of, I guess, the public work that's being done using R with sports data has really advanced the use of data visualizations and embedded it into things that are really familiar for sports fans. So, just recently we had the Australian Open. Tennis Australia has a group called the Game Insights Group, which is a data analytics group. They primarily work with the broadcast side of tennis. And they were publishing throughout the 2 weeks of the Australian Open, this is ggplot with some tennis courts laid underneath. And so what we can start to see is, for example, this is during the Team Zverev game, semi-final, men's singles semi-final. During the match, we can retrieve high quality data from Hawkeye, produce a simple visualization, relatively simple, and tell a story. Which in this case, from a sport point of view, is that Team had a more varied tactical approach to where he stood when returning first and second serves. He was either deep, so back by about 5 or 6 meters behind the baseline, or right on the baseline. Whereas Zverev was very predictable when he was returning Team's first serve. He was about 1 to 2 meters behind the baseline. And that's interesting from a viewer's point of view. It's interesting from a tactical point of view. And it tells you something about how the game is going, but not just from watching the vision. It tells you something deeper about the patterns, the persistent patterns. And this is also then folded into the broadcast. So the Game Insights group were feeding insights highlights to your gym couriers to say so-and-so ran X number of kilometers. The usefulness of totals and things like that is a whole other discussion, but it's cool to see data being normalized and part of the sports discussion and not pushed out. A piece of research that I'm working on at the moment with a PhD student is looking at sleep behaviour. So we can track people's sleep using wristwatch actigraphy. It's effectively a watch that tracks accelerations when you sleep, and we can track things like what time you fell asleep, what time you went to bed, what time you woke up, how long it took for you to fall asleep, so sleep latency or sleep onset. The duration that you were asleep, how many times you woke up in the night, how long those wake bouts were. This particular heat map is just bed and wake times effectively. So I've taken when someone went to sleep, when someone went to bed, and then they're shaded in between. And so we can start to see in a team of players when the bulk of the team is sleeping and when there starts to be some people waking up or going to bed. There's a Shining app by Todd Schneider, which uses hex bins and takes ideas from spatial analysis to produce shot charts. So if you're a basketball fan, this will either be familiar to you or scary to you, depending on whether you go for the Golden State Warriors or not. Steph Curry is an incredible player who's completely changed how you're supposed to shoot a basketball. His efficiency and accuracy from a range of places on the basketball court is quite amazing. So this chart, you can see, I don't know about the color choice, but the purple in there is lower than the league average. If it's sort of that aquamarine teal color, it's on the league average, and anything that's green or yellow is above the league average for field goal shooting accuracy from that spot. So you look at that, there's a lot of green, a lot of yellow. It's something we already know about Steph Curry, he's very accurate, but when you compare it to other NBA players, he's exceptional. There's also a lot that's been done in the space of analysing data. So we looked at applying this idea of draft curves. This is not new work in sport. It's the idea of taking an economic kind of view of player drafts. So in professional sports, there'll often be a pool of aspiring players, often juniors who are about to progress to senior level, and teams will be assigned a set of picks. And pick 1 is the first pick of the pool, and given that we are sampling without replacement, I think, is that right? When it comes to statistics, it's been a while since I did my statistics courses. It means that the first pick, you get the opportunity to potentially pick the best player if you can use that strategy well. But we're interested in, does anyone have a lock on this strategy in the Australian Football League? So one metric, not the only one we looked at, but one metric, one very simple one, was number of games that a player played across their career based on where they got picked. And as you might expect, players that got picked earlier play more games, players that get picked later play fewer games. There's a bunch of reasons for that, right? There might be a sunk cost fallacy thinking here, where we spent a pick number 1 on a player, and so we're going to give them more games because we want them to work out, or they're not working out, but we're going to give them more games to give them more of a chance. So there's a bunch of things here. We can't sort of separate out those complex factors. But I think what was interesting to see was the steep decline in value in terms of games played, and that it really levels out from about pick 40, which is only the second round in AFL. So that's kind of interesting, is that you could potentially have pick 100 and still get heaps of value. We also did comparisons by team, so we could look at whether certain teams seem to have an effective strategy at any particular point in the draft. And we can also look at things like win probability. So ESPN have a win probability model that factors in a range of things. They don't publish the model itself, but they say that it factors in historical outcomes between teams, time in the game, scores and whatnot, things that would make a lot of sense to include in a win probability model. And we can use the NCAA Hooper package again to produce win probability charts. Now, on its own, it's got a cool, pretty graph, but for a sports scientist, the thing that's cool about this is to then map that to the game, the vision of the game. So we can look at points of change in win probability and maybe try to identify what were the things leading up to that moment that changed the probability of winning in our favour or for the other team. And I've got an eye on the time, and I know Simon stood up to give me a little nudge. So there's a bunch of things that I think we can improve in sports analytics. We often come from an academic background, as JJ spoke about, and so we are very comfortable working in these internally consistent projects, but less comfortable with ideas of pipelines. And if we're going to be more systematic and able to pass our work on to the next generation of sports scientists, we need to shift our thinking in that space. We need better infrastructure that connects data that exists in multiple formats and multiple sources. We need to learn how to work with version control systems. I'm pretty pleased that our team works with Git, RR Studio. We connect that to our SQL database, and we've got a pipeline going, but that's not without a lot of support from our software engineers who support us as consultants. And as a bigger picture piece, integrating with other functions of an organization, a sports organization, and working in partnership with decision makers is really important, so that analytical functions in sport don't end up just being the geeks in the corner. Thanks.
We only have time for one quick question, so if you want to end while
Which is
we're
great.
switching speakers, because
Yep.
otherwise it's
No, all good.
what's up.
Thanks.
If you have, if you can read one question from that.
Sure. So the question that the first one that popped up was, do you wear a Fitbit, Garmin, or other wearable, and is the data just too dodgy? Garmin is quite good. We use them with athletes quite often. I'm often on the lookout for validation studies and measurement quality tests. We would generally do those tests before we use them with the elite athletes, but in terms of ourselves, there's a mix, and some people are very happy to use Fitbits, which are less accurate. The main thing, if you do use them, is that usually they're pretty good in terms of measuring change for your own behavior, but when you're comparing to other people's data sets, then it gets a little wonky, so just be cautious of that. Thanks.